It's time to look deep within the machine and understand what really happens when your Python code executes. We're code walking through the CPython codebase and visualizing it at pythontutor.com. This is episode number 22 with Philip Guo, recorded Monday, August 3rd, 2015.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes it can
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy, and keep up with the show and listen to past episodes at talkpython.fm. Be sure to follow the show on Twitter where it's at talkpython. This episode is brought to you by Hired and CodeShip. Thank them both for supporting the show on Twitter via @HiredHQ and @CodeShip. Now let me introduce Philip. Philip Guo is an assistant professor of computer science at the University of Rochester in New York. He researches human-computer interactions with a focus on user interfaces for online learning. He's especially interested in studying how to better train software engineers and data scientists. He created a free web-based visualization tool for learning programming called Online Python Tutor at pythontutor.com, which has been used by over 1.2 million people in over 165 countries to visualize over 11 million pieces of code. Philip, welcome to the show.
My pleasure.
Yeah, it's really exciting to have you here. We're going to talk a lot about many things. We're going to talk about CPython and a really cool project that you put on your website and on YouTube called CPython, a 10-hour code walk. And so we'll be digging into CPython, and we're also going to talk about this thing called Python Tutor at pythontutor.com that you are working to help people understand the internals of Python better. So that's going to be great stuff.
Cool. I'm looking forward to it.
Yeah. Before we get into the details, though, everyone likes to know how people got into programming and how they got started in Python. What's your story?
So my story was I was always interested in computers as a kid, like many people who got into computer science, but I never really had a strong programming background until I went to college. So I tried to learn QBasic by myself when I was 10, and that, I had a book, and then that failed after a few weeks because I had no one teaching me. I took an AP computer science course in high school. That was in C++, and that was really fun. And that was kind of my first introduction to really doing programming. And in college, I decided to major in electrical engineering and computer science. And that's when I started just learning programming formally. But really, the Python relevance is I didn't actually start hacking for fun until about my senior year of college. And the first language that I learned for programming for fun, and not just because I had to do it for class, was actually Python. So the first kinds of programs I wrote were scripts to manage my photos and, kind of manipulate and manage my own personal photo gallery and, put it up on a simple website. So that was where I started getting hooked on Python. That was about 10 years ago. That was around 2005. That was like Python 2.4 or something like that.
Yeah, that's a great way to get started. I think a lot of people have interesting stories like that. Just they have some small problem they're trying to solve, and it leads you down this path, and all of a sudden you discover this world where, hey, there's this great thing, programming or Python or whatever.
Yep, that's exactly right.
So I see you're calling in from Seattle, right? What are you doing up there?
So I am currently an assistant professor of computer science at the University of Rochester in upstate New York. So that's nowhere near Seattle.
That's what I was going to say. It's not at all in Seattle.
So I get to, one of the real benefits of being a professor is that your summers are free to do research or to travel or to do other sorts of scholarly work. So most professors at most terms, they stay on campus in the summers and they do research full time for 3 months. What I decided to do this summer, since I had some colleagues at Microsoft, was to spend most of my summer at Microsoft Research, doing research in both in software engineering and in online education at the lab in Seattle. And I came here because I actually was an intern here a long time ago when I was back in grad school. So I'm actually back interning in the same group. So it's sort of a homecoming of sorts.
Back to the Future. That's excellent. Yeah, I've done some work with some of the guys up at Microsoft. It's a cool place up there. So excellent. Is this related to PythonTutor.com?
No, not really. I mean, this is just a completely separate sort of research project. So there's nothing Python related in the in the work here, unfortunately.
All right, cool. All right, so let's talk about your CPython internals class. This was a class you did at University of Rochester, right? 2014,
yes,
I think.
Right.
Is at least the recorded version was 2014.
Yep. So this was a class I taught in fall 2014, and it was the name of the course was Dynamic Languages and Software Development. So I actually inherited this course from another professor who was taking a leave and teaching another class that term. And that class was originally in Ruby. So it was sort of a graduate level programming languages class about these sorts of dynamically typed languages. And originally he did it in Ruby, but since I knew Python a lot better, I revamped the class to be in Python and basically turned it into what the videos are online. So I'd be happy to talk about that in detail.
Just for everyone listening, the videos are online, and I actually spent like the last week going through your class. So I feel like I've had like some super intense summer course or something, doing like 10 lectures. And people can find those on your website at pgbovine.net/cpython-internals.htm. And I actually went through, unrelated to this conversation or maybe preceding this whole having you on the show, I just saw your videos and thought they were awesome. And I put them into a YouTube playlist at bit.ly/cpythonwalk. So both of those work well. What was the main goal of the class? Sort of get people to understand what happens when you actually run dynamic code like Python?
Yeah, I think that was basically philosophy. So a lot of programming languages classes are taught from more of a theoretical perspective, right? So it's usually kind of some formal syntax and semantics and maybe doing some proofs, and it's very, kind of formalism heavy. And I thought it would be interesting to do a very different sort of class for graduate students from the opposite side, which is something extremely applied. So saying, here is a piece of Python code. Let's start with hello world or a simple for loop or a simple function call. And what actually happens throughout all the steps between that code being parsed and then the output appearing on your screen, let's say. So I wanted to dive into the interpreter and show students how everything worked under the hood and how there's really, by deconstructing, you can show that there's really no magic here. There's just a lot of C code behind the scenes that keeps track of a lot of stuff, and eventually your program runs. So we don't do the parsing stage because I think parsing is fairly standard, and that's covered by most kind of introductory compilers classes. You write a grammar and parser generator, and some code gives you like an AST, and then that gets walked to turn into some kind of bytecode. So the class actually starts with, assuming you have a bunch of Python bytecode, how does the bytecode actually get interpreted step by step by the interpreter and runtime system to do your program's operations?
Yeah, that's really cool. And I think, if I think about how like C code runs, and then my intuition about how that C code actually executes. If you understand a little bit about registers and memory addresses and pointers, your intuition more or less will carry the day, I think. With interpreted languages, all bets are off, right? I mean, you have some concept of the programming language doing things, but then the way that happens, you really have to look inside, right?
Yeah, exactly. Because these interpreter languages are often not implemented like you would conceptually think of it, right? You think of something as you have frames and variables and pointers to each other, but really these bytecodes are this sort of, the Python one is sort of this stack-based kind of virtual machine. I think the Java virtual machine is that way too, but I forgot the exact semantics. But it's not something you would think about normally, but they do it that way, one, because it's really compact, and it's kind of leads to really compact code and sort of easy to understand code for the implementer. But that's very different than the conceptual model in your head at the very high level, how a program ought to work. And we can talk about that later when we talk about the Python tutor as well, because that kind of leads into that other tool. So we can keep talking about the CPython stuff first.
Sure. So one of the things I thought was interesting was in your very first session, you have kind of a cool whiteboarding thing you're doing with a Microsoft Surface and like a pen where you can kind of draw on the code, and that's cool. You do a cool little sketch about what actually happens when you type Python space sumefile.py. And I mean, on one level I knew it, on the other it was a little surprising to me to say it. And the first step is compilation. Could you maybe talk just briefly about like what happens when I run my Python code before we get into the interpreter itself?
Yeah, so many people are surprised when there's a compilation step in Python or in these sorts of dynamic or what people call scripting languages. Because usually you think of running Python space whatever or Perl space whatever, Ruby space whatever, and it just runs, right? Whereas,
right. I just thought, here we go with the interpreter, and now it's interpreting, right?
Right. So with Java or C or C#, you have a compilation step, and then you run a compiled binary, and there's two separate steps. But with Python, as with many other languages, the compilation happens before the execution. So what happens is, as a standard kind of a front end to a compiler, it takes the source code, it does the lexical analysis, it does the parsing, it creates a AST or abstract syntax tree from it, and then it walks that tree and creates a bunch of bytecode. So the Python bytecode language, you can read in the documentation, it has, I don't know, a few dozen operations like add, load, store, and also some operations that are a little bit more Python specific, like build a list, build a dictionary, build a tuple, function call, those sorts of things. So the compilation step really takes your source code, which is in somewhat human readable form, and turns it into a linear stream of instructions, very much like assembly language, except you can think of bytecode as an assembly language for a Python virtual computer.
Right. That was kind of the impression I got as well, like a much, much richer assembly language where you have operations like build class and call method, push and pop stuff off stacks and so on.
Yep, exactly.
If we want to go work with this, right, we can go to python.org and download the code and decompress it or untard or whatever. And it literally is a bunch of C code, right? The C in CPython is, here's your C implementation of this interpreter, right?
That's right. So if you go to, this is what I do on the first day of class. We have everybody download the C interpreter source code from, the CPython source code from python.org and unzip it and do configure and make. Now, part of the class, I didn't require students to actually run the interpreter if they didn't want, because most of the class was actually reading through the code and walking through it. Now, the students who were a bit more adventurous, they could try to compile the interpreter themselves and then try to put in debug statements or print statements to see how it works behind the scenes. But actually, compiling the interpreter itself might not be easy if you're on, especially on a Windows machine, which doesn't have a lot of development tools and compilers. Usually on Linux and Mac machines, if you install the standard developer tool chain with GCC and make and configure and all that stuff. In theory, right, building is always hard, but in theory, if you do /configure and you type make, all you'll actually call the C compiler on your machine, and it will compile all the C files in the C and the H files in the CPython /directory, and in the end, it will produce a binary executable file called Python, and that Python you can just run, and that is the Python interpreter that you just compiled from C source code. So most of the class, what we do is we go over what a lot of those C files actually do in C.
Maybe you could give us like a 10,000-foot view of what are the interesting parts of that source code and what is just noise and details. So there's like objects, and then there's include, there's ceval.c. There's like a few really common parts that you come back to over and over and over, and then there's a bunch of details.
Yeah, so on the website with all the videos, I actually show the files that they reference. But really, the core file that I keep on going back to, like you're saying, is in Python /ceval.c. And what that is that file at its core is the main interpreter loop. So conceptually, how Python executes code is a bytecode is just a bunch of it's just a list of instructions. Each one is add or subtract or build list or function call or so forth. And all the interpreter does is just go through one instruction at a time, take it off the list of instructions, do something, and then move to the next instruction, do something, move to the instruction, and then do something else. And it might jump around the stream of instructions if you have, say, a function call or a loop. But really, the main interpreter loop in C eval.c, all it does is just a big while true infinite loop that just...
Yeah, there's like a huge switch statement, and it is huge, right?
That's right. Yep, there's like a 3,000 or whatever line switch statement. There's a fun fact in there. If you actually, I don't know if it's in all the versions, but at least in some of the versions I saw, there's some kind of comment in there saying that they needed to like break up the switch statement in some weird way because some C compilers just can't take switch statements that are that big. So they had to actually break up the code into pieces because, it wouldn't compile on some kind of computers because that code was just too giant.
Yeah, that's pretty funny. It's like a 3,000 line switch statement. It's pretty cool.
Yeah.
But those are more or less the steps that all have all the opcodes. And so if I look at Python, it's not necessarily mapping one-to-one the Python code I write to these opcodes, which is a good thing for Python programmers, right? That means you're working in a high-level language. You're not working like down in the detail, right? But it also means it's hard for me to understand if I write, create a class and I say, T equals new test class. What does that actually mean? Like, how do I line that up? And so you had a cool way to disassemble that, right? And look at it. This episode is brought to you by Hired. Hired is a two-sided, curated marketplace that connects the world's knowledge workers to the best opportunities. Each offer you receive has salary and equity presented right up front, and you can view the offers to accept or reject them before you even talk to the company. Typically, candidates receive 5 or more offers in just the first week, and there are no obligations, ever. Sounds pretty awesome, doesn't it? Well, did I mention there's a signing bonus? Everyone who accepts a job from Hired gets a $2,000 signing bonus. And as Talk Python listeners, it gets way sweeter. Use the link hired.com/talkpython to me, and Hired will double the signing bonus to $4,000. Opportunities knocking. Visit hired.com/talkpython to me and answer the call.
Right. So the disassembler actually comes in the standard Python library. So if you do Python space -m space dis, which runs the dis module space the Python file name of your Python file, will actually run the main function in the dis module. And what that'll do is that'll actually print out a somewhat human readable representation of the bytecode. And the cool thing about that is that it shows the line number of which line of your Python source code compiles into which bytecodes. And as you mentioned, it's not a one-to-one mapping. So one line usually compiles to several bytecodes because the bytecode is at a lower level. So you can run that dis command. And the dis module, you can just search for, I think if you search on your favorite search engine for Python space dis, you should see the documentation for this disassembler module. And that is in the standard library, and that gives you all of the stuff. So now that said, though, that only prints out the instructions. There's somebody who made a library called Byteplay, which is Byteplay, and that library actually is an enhanced version of the disassembler that lets you get the disassembled bytecode into objects, so you can actually play with it yourself. Like you can manipulate it, you can take it apart, you can analyze it. So this Byteplay library, I haven't used it myself personally, but I know people who really like playing with it.
Yeah, that's cool. A little more powerful. One thing about the dis module is it's super easy to look at just sort of flat code in Python files. But if I want to look at the functions, or I've got nested functions and classes, it's a little more work to do that, right?
Yeah, so the the default with the dis module is it just disassembles the top level of your program. So all the top level says is that if you define a function, it'll just say function definition. And then what you have to do is you actually have to go inside that function and disassemble that function itself. So it is a little bit more hairy. And I don't know if BytePlay handles all that out of the box, but it might. But the idea is that the dis module, if you just run it by default, it'll just disassemble the top level program, and any functions will not be disassembled automatically. You have to actually grab the code of those functions and go in there and call dis on that. So it is a little bit more tricky to do that.
Sure. The other thing I thought was interesting is if I've got a function, let's say foo, in Python, I could say, what is it, foo.func underscore bytecode. How do the bytecode is actually there on the function, and you can look at it in its encoded form, which is kind of some binary string type thing. And then you can also disassemble that as well, right?
That's right. And that's what I think we're just leading into that. So the idea is that dis itself, if you just run it, it disassembles the bytecode of the top level file. But each function itself has its own code. And like you said, I think it's actually different in Python 2 and 3, the name of it. But I think in one version, it's like the function object dot func underscore code. The other one is just dot code or something like that. But the idea is that the code of the function just appears inside of it as a binary string of data. So if you actually print it out, it just looks like some garbled string. But if you run it through some, you can run it through some pretty printing function or through dis, and it actually shows you the bytecode of the function, because all a function object is that it's some context plus an actual string of bytecode that represents what the instructions are that the function is supposed to execute when you run it.
Yeah, the other thing I thought was pretty cool or interesting to understand is that sort of compile step that you talk about, right? When I run my Python file, I get first like a compile step to bytecode and then the dynamic interpreted execution. But all those functions and stuff, that bytecode is there and ready to roll. It's just not kind of wired together until it gets to the interpreter, right?
That's right. So you can actually compile I think it's just the Python interpreter does the compiling and running all at the same time. But I think there's actually a mode in Python that you can just compile the bytecode and not actually run it yet. I'm not sure exactly which flags are that what it is, but sometimes people actually ship pre-compiled Python bytecode instead of the source code. So I don't know what reason people do this, because you can just run the source code and some people like to obfuscate their bytecode maybe, but I don't know how well that actually works, because you kind of reverse engineer it. But so the compile step is completely separate from the running step, and like you said, once you compile, it's just a bunch of, instead of a text file, a .py file, it's called, I think, a .pyo file or something. It's just a bunch of garbled stuff, and then that garbled stuff you can just run through the interpreter and it'll run with your program.
Yeah, it's really interesting to see how it's all coming together. What do you think some of the main reasons for studying Python at this level are? Like, how does it make you a better programmer, do you think?
That's a great question. I think that studying Python at this level, of the implementation level, kind of makes you, I feel like it makes you a better programmer in that you kind of build a really good mental model of what goes on behind the scenes, and you see that these languages are just tools made by people. And I think there's something really powerful in that. I feel like this is a very kind of systems perspective of programming. So one analogy is that, why do people study, say, operating systems or study compilers? Well, it's a good example. Like the kind of classic thing in college is that a lot of people have to take an operating systems course where they build a very simple sort of OS kernel in C and maybe some assembly, and their kernel kind of runs and it does a simple hello world. Or you do a compilers course where you build a compiler using some basic building blocks. And the idea there is that it's not that you're going to ever build an operating system or a compiler in real life or a new programming language. Most people are not going to implement a new kind of programming language, but by studying the principles behind how it works, I feel like I think it makes you a better programmer in that you kind of understand how large, complex code bases are organized and logically broken down. So I view this class, like you've seen with these videos, as more of like a code reading or literature exercise in a way, right? Because we're actually reading through dozens of, actually not that many, maybe a dozen really core complex files and seeing how they the pieces fit together. So it's sort of like dissecting, kind of a large piece of code. I think that's really interesting in its own right.
Yeah, a lot of people when they're in school, at least studying this stuff, it's all very, I don't know, like you said, abstract, or maybe not. It's not quite what I'm looking for, but like. It doesn't have the nitty-gritty details of the real world applied to it. So all the error conditions that are so bizarre and all the optimizations, you don't necessarily have to deal with that. And so when you do finally get to a real world complex code base, it's super hard to feel comfortable. And I think, you kind of helped your students do that a lot in there. So that was cool.
Yeah, I think that's, and like you mentioned, there's always a trade-off, right? So even in my choice of what to cover in this class, if you notice, I only cover maybe a dozen or so files. The Python code base has hundreds or thousands or of source code files. And obviously I don't have time to cover all of it. And two, I feel like this dozen is really the conceptual core of the interpreter. A lot of the files are just modules, right? A lot of the files are just like, here's how strings are implemented. Here's how the socket class is implemented. Here's how, memory mapped IO is implemented. Those are all, I feel, auxiliary things. But whereas the core thing is, what is an object? What is, a class? What is a function? What is the interpreter? And even as you notice from watching the videos, I don't go over every single line in excruciating detail. I basically gloss over things and say, look, this block happens if there's some kind of error, you run out of memory. So, look at that, in spare time. But
Exactly.
Here's like conceptually what happens. So it is a balance of, exposing students to the nitty gritty, like you said, but also not too nitty gritty because there's so much complexity in the code that isn't core to the lessons of the class. So it's a balance.
Yeah, a lot of times as programmers, we are, to be effective, we have to kind of zoom in, look at the tree, zoom out, look at the forest, zoom back in on another tree, zoom back, and that skill of like in and out is pretty awesome. We talked about the opcodes. That's one, and that eval.c function or a class where it has the main eval loop running around and around. That's one of the main architectural pieces of CPython. Another one that struck me was everything is this type of C object called PiObject.
Yep.
Everything is a PiObject, right? Pretty much. So numbers, strings, custom classes, those all kind of make sense. But even the class definition itself, functions, methods. So that was really interesting to me. And then we have derivatives of those, like things that have PiObject kind of as their base class, like PiIntObject for int, PiListObject for lists, and so on. But C is not an object-oriented language. So how's that work?
Right. So like you mentioned, the PiObject structure, I guess, in C is the base of how everything is implemented. All the objects are implemented in Python. And what that contains actually really few sorts of basic data. And I think the most basic, I'm trying to remember off the top of my head, is one is a reference count of how many pointers are pointing to this object at once. And it's because Python implements garbage collection by doing reference counting. So if you have nobody pointing to you, then you get garbage collected and your memory gets reclaimed. So everything is conceptually a subclass of PiObject. So if you want to make an integer object, it's a PiInt object. Or if you want to make a string, it's a PiString object. If you want to make a function object, it's a PiFunction object. And like you mentioned, C is not object-oriented language, so there's no inheritance in the language. But really, you can fake it by basically doing what's called structural inheritance or structural subtyping. What that really does is it's a hack where you basically create a struct where the first few elements of the struct are exactly the same as the base class. So basically the PiInt object, I don't have the code in front of me, but the PiInt object, the first whatever.
What is it? Type? Like the class, the original type, and then the ref count, like you're saying, right?
That's right. So those are the two things in PiObject. That's right. So there's a pointer to the a tag saying what type it is, and then there's the number of references. So every struct that represents some kind of a Python class, all the names are getting mixed up, starts with those two things. And the cool thing there is because if you have C code that expects a PiObject star, a PiObject pointer, and operates on it, it knows that the first thing it accesses in memory is the type, and the second thing I think is the reference count. So all of your code will work perfectly fine if it's an int object or a long object or a string object, if the function you're passing it into expects just a base class of PiObject. So basically, conceptually, it's just subclassing or subtyping, but that's how it ends up being implemented in C. And actually, how C++ does subtyping, I think, in its most basic form, is basically that. Because C++ is meant to be compiled to be somewhat backwards compatible with C. So this idea of piling another class on top of another one structurally with the fields in the same places is a pretty classic technique.
You kind of absolutely. You kind of have to really understand C pointers pretty well to get it. But once you do, it's pretty straightforward, right? Because when you say pointer and you dereference that pointer and you say a name, that really just maps to like an offset from the base address. And long as they all have the same shape up to that point in terms of in memory, you basically have inheritance, right? That's cool. This episode is brought to you by CodeShip. CodeShip has launched organizations, create teams, set permissions for specific team members, and improve collaboration in your continuous delivery workflow. Maintain centralized control over your organization's projects and teams with CodeShip's new organizations plan. And as TalkPython listeners, you can save 20% off any premium plan for the next 3 months. Just use the code TalkPython, all caps, no spaces. Check them out at codeship.com and tell them thanks for supporting the show on Twitter, where they're at CodeShip.
Yep, exactly. And that's another kind of a side effect of studying this sort of studying implementations, because most implementations are usually in C. So you get to kind of see these interesting C tricks and see how other languages are built on top of that, like object-oriented programming.
Yeah, it's cool. I definitely have a better appreciation for macros after spending 10 hours looking through that I did. Because I did a lot of C++, but not a lot of pure C. So, some of the tricks you might do differently in C++, almost, have really nice macro solutions. So that's cool. Your other project, Python Tutor at pythontutor.com, what's the relationship to this? I mean, certainly pythontutor.com helps you understand the sort of in-memory, what's happening inside your Python code. So I kind of see these things as somewhat related, these two projects that you had. Maybe you could just introduce Python Tutor for everyone, and then we could talk a bit about it.
Sure. So Python Tutor at pythontutor.com it's a web-based tool where you can write Python code. And actually now you can write code in a lot of other languages. So you can write code. It supports Python, Java, JavaScript, TypeScript, which is a Microsoft version of JavaScript with types, which works really well. And also Ruby now. What you do is you write code in your browser and then you run it. And it actually it sends your code to a server to run in a sandbox. So it actually runs a real version of the language and not some kind of JavaScripty simulation of it. So it runs the code. It sends back the execution trace, which is everything that happened when your code ran. What it did at every step, when it printed out, what variables there are, what data structures there are. And then it produces a visualization for you that you can step through. So it produces a visualization of every step of the code execution, and then you can use a slider to go through it and see that the variables being created, the function stack frames being created, the pointers that are pointing to each other. And what that lets you do is that lets beginners especially build up a mental model of what is kind of going on inside their program. Because even for code, for experienced programmers, we actually build up this model ourselves, right? We look at a piece of Python code and we think in our heads, oh, there's a variable here that's pointing something else here, and that's pointing this other thing here, and then we call a function, and that function points to the same thing we do. But those structures are really hard for beginners to build up in their heads. And this tool's just been really helpful for a lot of people to build up that model. And the relationship between that and the CPython stuff is actually really interesting, because the CPython stuff is really for advanced learners who want to learn how things really work behind the scenes. And like we mentioned earlier, the Python tutors, for most people, I think it's more useful because it's really what happens. It draws the pictures of what happens at the conceptual level, right? That you're actually conceptually, all you want to think about is you run every line of code and something happens. You don't need to know about the bytecode or the stack or the the main interpreter loop or PiObjects or everything. So I think those two are really complementary. One is for advanced kind of programmers who want to study internals, and whereas the Python tutor is for beginners who are just learning the language.
Yeah, that's for sure. I kind of saw it the same way. I feel like, there's sort of this understanding of the thing that is CPython, and Python Tutor has this great way to help beginners kind of form good mental models, and your CPython walk is really good at actually showing a super deep understanding, but they kind of give like two perspectives of the same thing. So even though I've been doing Python for a long time and I know C really well, or C++ anyway, I still thought that just looking at the stuff that was going on in Python Tutor, like it has some really great visualizations for showing basically like scope, variable scope and things like that, because that can be kind of hard to understand for beginners, those kinds of things, right? Like, because it's not just, it's in the curly braces, and so when it leaves the curly braces, this variable is gone, right? There's a whole different mechanism for finding what's defined where and so on.
Right, that's right. And also with the nested scopes and closures in Python, that gets even more tricky. So the Python tutor has a way of visualizing kind of your parent frame. So if you, for example, the classic case is if you define a function within a function, that inner function has access to the outer functions variables as well as the global variables. And it gets even trickier when you have a function foo, and inside of foo you define bar, and bar accesses something within foo, but then foo returns bar to its caller, and the stack of foo is gone. But when you call bar again, you can actually still get back to the variables that foo had, even though foo has finished executing. And the Python tutor and these sorts of tools visualize that for you. And it's been used by quite a few classes, especially to teach these things like nested functions and closures, which are not as obvious, and they're more advanced concepts.
Yeah, I do professional like training for Python and other technologies as well. And I was thinking I'd probably pull that up when it gets to the scope stuff for students.
Cool.
Just, because
definitely.
I'm teaching a lot of guys who have done C++ or .NET or something like that, and just their mental model is not appropriate, right? And it's just like seeing it is a lot easier than spending 5 minutes talking about it, writing some demos. So I think that's really cool. I think it can help a lot in those areas as well.
Yeah, definitely. Please use it and let me know if you have issues. I mean, it's pretty robust at this point. I mean, the thing is, it does require an expert such as yourself to guide people through. I mean, it's helpful for people by themselves, but if you just, what people do as instructors, like yourself, is you just pull up a browser and start writing code and start running it and start explaining the code to the students one step at a time. And that's a lot more useful, I think, than starting a terminal, right? Because the alternative now is you start a terminal, write a function or a nested function, whatever, and then put a bunch of print statements inside. And then you just run in the terminal and just print a bunch of stuff. And you're like, okay, I got to explain why it's printing this. But whereas in the Python tutor, it's printing it to the web terminal. But then also every step you see, it's printing this because X is now pointing to this. And now X points to something else and it's printing that. And it's extremely clear.
Yeah, it is very clear. And it's like, if you were to do your terminal example and then go over to the whiteboard and sketch out what's really happening as you try to describe it, like Python tutor just does that drawing for you, right?
Exactly. So that the exact use case is what you said. Of it really replaces a combination of a terminal. It really replaces a text editor, interpreter terminal scene like a REPL and a separate whiteboard all in one. And I thought it was really interesting. You mentioned the .NET kind of the C/.NET developers switching the mental model of Python. A funny story about this is recently I wanted to learn Ruby. I've always wanted to learn Ruby for a while. I've never done it before. And I felt a good way for me to learn Ruby is to actually write my own Ruby backend for the Python tutor. So the Python tutor is actually, it's a very it's a language independent interface. If you notice the visualizations, nothing about the visualizations has Python. They're just variables and stack frames and functions and lists and objects with attributes and stuff. And you can imagine squinting, and that makes sense in another language like JavaScript or Java or Ruby. So what the backend does is if you actually write a backend, say in Ruby, by hooking into the Ruby debugger and printing out what happens at every step, you can actually generate visualizations for Ruby. So I actually spent about 2 weeks really deep diving into the Ruby language implementation and debugger and how it works. And I actually created the backend for Ruby, which is live on the site. And that actually gave me some really interesting revelations about how scoping especially works in Ruby. Have you done Ruby before?
I started to learn Ruby on Rails a little bit, played around with it, never really got very far with it.
Yeah, it's we could do a whole other podcast on that. I think people who've done Python for a long time, when we learn Ruby, it just seems crazy and weird. And I'm sure Ruby people say the same thing with Python. The scoping is really weird. So I have an example, a Ruby scoping example is like something that really looks basic in Python. You're like, oh, this ought to work a certain. So I'll give you a classic example is if you have what looks like a global variable, like, x equals 5, and then you define a function in Ruby. Inside that function, you cannot access the global variable.
Okay.
It's like insane. And it's because it actually, when you define a global variable, it's actually not a global variable. It's a local variable in that scope. And when you define a function, like what it looks like a function, that's actually a method on the default object, which is outside of the scope of your normal thing. So it can't actually access what you think is a global. So if you actually think of things in a Python way and you're doing Ruby, it gets super confusing in terms of scope. So, but the Python tutor actually illustrates that all for you. And it's like, oh, wow, I can see why I can't access that variable, even though I thought by looking at the code I could.
Yeah, and that way I think Python Tutor is really interesting for experienced developers because we have these really strong mental models, but they're not portable necessarily, right? You can't just plug them into different situations. And so seeing the differences might just quickly, connect those two together.
Exactly. And I think that's why I've been extending it to other languages, because I want this tool to be useful not only for someone who's an absolute beginner who's never learned anything, but also for experienced programmers. And one of the future pieces of work I love to get into, if I have time, is to kind of make the bridge between different languages. Now that Imagine Python Tutor is this nice visualization that is pretty much language agnostic, I want to see one awesome thing would be like, if I'm a Python programmer, I want to learn Ruby, I want to write some Python examples and then see some equivalent or similar Ruby examples and step through their code and see, oh, this is how you do this, do lambdas or do nested functions in Ruby. It looks kind of like Python. So I think that with this tool, because it's on the web, people can build up interactive examples showing how different languages differ from each other.
Yeah, I think that's actually really valuable. Although you might need a 301 redirect to a language tutor or something like that, right? Yeah,
the name is funny. Yeah, the name kind of stuck because it started with Python. I debated changing the name for a while, and the domain's really good, and it's pretty highly ranked, and a lot of people know it. So I think it might just be an inside joke. I might just have to stick with Python for now, even though it supports these languages.
Yeah, of course, it's cool. So that's all really well and good for helping. Before we move on, I guess, let me go back to one thing. One other thing that I think is really helpful, even in this mode that we've already spoken about, we'll get to the other modes that we have available in Python Tutor as well. But one I thought was really cool is forwards and backwards execution. So I'm a huge fan of PyCharm, and PyCharm has really nice interactive debugging. And, speaking of Microsoft, you're around, somewhere physically near the Visual Studio guys, and they have Python tools for Visual Studio, which have nice interactive debuggers. But going back in a debugger is not the same thing as actually forward and reversing time. And I think that's one of the things that's cool about Python Tutor is I can run forwards. Oh, wait, I didn't understand what happened. Let me go back 3 steps, forward 2 steps. That's a really cool feature.
Yeah, and I think that's one of the key features. And people have been trying to do reverse kind of debuggers in production for a while. There are actually some teams, doing stuff for various languages. I mean, in production, it's really hard to do, but in this educational case, the forward and backward is sort of a trick, because what happens is the whole program has already executed by the time you see it in the browser. So when I'm scrubbing forward and backwards, I'm just looking at different pieces of the log that the program has already done. So that's really nice, because it allows you to go forward and backwards arbitrarily. It's not like I have to re-execute it all. The whole program is done. I'm just seeing what did it do with step 1, what did it do with step 2. and such.
That's awesome. Yeah, there's not like an edit, continue, or drag the execution pointer to skip this if check or something like that, right? Not real.
That would be cool, but that would be cool, but it's a read-only view. It's just, it's done. This is the program you wrote. Let's just see what happens at every step.
And I think that's amazing. So the other thing that you can do that you seem to be building out more and more is to bring other perspectives into this. So if I go run pythontutor.com and I go click some stuff, it's like an automated system showing me stuff. But if I wanted to sit over the shoulder of somebody and help them understand it, or if I was teaching a class and a bunch of people doing it, you've got tools for that as well, right?
Yeah, so the immediate tool, it's all on the site right now. If you look at, if you go to the Python Tutor site, there's a Start Shared Session button on the upper left. And what that does is that it actually creates a unique URL that you can send to your friend or to a tutor or to a TA. And when they join that URL, they actually get into your session. So it's like you're both virtually in the same session that are sharing it. So what you can do is you can write code together, just like you're in Google Docs. And then you can actually when you run the code, your visualizations are synced up. So you can actually, when you step backward, the other person's screen also steps. And then there's a chat box so you can talk to each other. And you can also see each other's mouse cursors. So that simulates the experience of, say, a tutor and a learner getting together and sitting side by side and trying to work out a piece of code together. Except you can do this anywhere and remotely. So we've deployed this for about a year now, and a bunch of people, like hundreds of people, have just used the service to do both tutoring, like remotely, just saying, I send a link to my tutor and they can tutor me and I don't have to be in the same room with them. And also people use it for collaborative learning, which is really neat. So this chat room supports arbitrary numbers of users. In reality, after you get to more than 4 or 5, it gets confusing because so many people are trying to write code together and chat, and it's
a storm of little mouse cursors.
Exactly. So because you see everyone's cursor. So I've seen people with 3, 4, maybe 5 people kind of talking about stuff. So that's sort of the tool that simulates a kind of personal interaction with the visualization.
Then you have another form that is sort of almost a dashboard of mini learners, right?
Right. So then there's another tool that I've been building that isn't exactly live on the site yet because it's really a beta for tutors only. And what that is that solves the problem of there not being enough tutors. So imagine if you're in a large, in a real class, in a college class, you might have 50 students in a computer lab and one tutor or a TA there. And what the TA has to do is run around the computer lab helping everybody, and people are raising their hands or going around helping one person, then someone else raises their hand and go around helping another person. In, say, an online course, a MOOC or these massive online courses, there might be 1,000 students for every TA on the course. And there's no way they can help everybody at once, obviously. So what I've done is I built a dashboard that shows a tutor or a teacher in real time what a lot of students are doing at the same time on a website like the Python Tutor. So this dashboard can show up to dozens of people, and each person's actions are just in a little tile. So it's like you have dozens of little rectangular tiles in a big dashboard on your monitor, and each one is updating in real time as the student is editing code or running code or seeing compiler errors. So then as a teacher, you can glance, and it's sort of like you're looking over the shoulders of, say, 20 or 30 students at once and seeing at a glance what they're doing. And most of the time, students are just coding along, or they're paused, or they're thinking. But then sometimes you see a student always keep getting the same compiler error, or you see a student changing their code back and forth and seeming confused. And in that case, you can start a chat with those students directly in the tile. So you can chat with any number of students you want, and each chat shows up directly in their coding session. And as a tutor, because you have this dashboard, you can simultaneously chat with many students at once. And the reason this works really well in practice is because a lot of students are just paused or thinking, so that you could jump in to help, say, 3 or 4 or 5 students at once. And it's not like you're chatting all the time. You're chatting, giving them a suggestion, giving them a pointer or something, and then they go off and do some work and you go help someone else. And you can do all that from the comfort of your own home without having to run around a giant computer lab. Or if you're in an online course, you don't know where the students are. They're all over the world, but you can just sit there in one central location and help, up to dozens of people at once.
Yeah, that's really awesome. So you've got all that in a blog post that's coming up pretty soon, right? Do you know when that's coming out?
Yeah, so I'm writing up a blog post. I don't exactly know what's coming out. Hopefully, it'll be in the middle of the month. I'm still kind of shopping around to different folks and seeing where I can get it published. But the research papers on these projects are coming out soon on my website as well. So all of these are kind of along the lines of my research projects, which all revolve around the theme of how do you build better interactive tools for teaching programming.
Yeah, awesome. Speaking of interactive tools, we had Brad Miller on from Interactive Python, and you guys are doing some work together as well, right? They're doing something with pythontutor.com to integrate that. Yeah,
so Professor Brad Miller, he was one of the first users of the Python tutor back in the day. So I started this project about 5 years ago as a graduate student, and I had 0 users. And it was just something I did, like many hobby projects, like many of these open source projects, it just scratched my own itch. I was teaching a bit of Python. I wanted to create some visualizations that helped myself out, and it was a fun thing to do. I put this project online for about a year or two, and no one really used it. I showed some friends and colleagues, and this is a kind of cool hobby project. But then around 2011, this was 4 years ago. Around 2011, Brad was starting to build some digital textbook resources. He had been an author. He's been a professor for probably over a dozen years, and he had written some Python textbooks. And he was trying to experiment back then in 2011 with putting his Python educational materials online in a digital format. And because he's really innovative, what he wanted to do is he was thinking, I don't want to just put some text and code online, because then it's just like, it's no better than reading a book, except you're just on the computer. I mean, it's better only in the sense that it's free, which is cool. I mean, that's already great. I mean, having a free digital textbook that's open source is great, because many more people can read it. But he's saying, if we're all already on the computer, can't we do something more interactive? So he found my Python tutor project and actually challenged me to try to make it so that you can embed it within other web pages. And theoretically it was possible because it's just a web-based interface, but I had to write a bunch of code to get it so that it can embed within other web pages. And we did that. This was 4 years ago, and I've been working with him ever since, on and off, to embed the Python tutor in his page. So if you actually look at his interactivepython.org digital textbooks, throughout the textbook, you'll see little widgets here and there that shows a piece of Python code with a slider through it, and then you can just slide, and then the visualizations actually appear. And then if you hit edit, you can actually edit the code in the Python tutor and see the visualizations. And I think that's been tremendously helpful for students, because they can not only read the code, they can actually see what's going on. And the cool thing is that all happens within the context of their normal interactive textbook. So Brad is an early power user and longtime power user of the system. So I'm glad you had him on the show.
Yeah, that's awesome. And the students can even kind of like customize the code samples and save them and stuff, right? So that's really neat.
Yeah, exactly. And that's the cool thing about being all online, that that you could not only say with the Python 2 with the visualizations, you can imagine someone making a visualization, right? Like an instructor using PowerPoint to very carefully draw out pointers and linked lists and data structures. And that's all good. But then what if, as a student, you're like, wait, I want to change this code to make it go backwards or something. And the cool thing about having a real tool, that you can just change your own code and see the new visualization, and instead of just seeing what the teacher imagined.
Yeah, that's wonderful, because that playful exploration is sort of key to becoming a good programmer, I think.
Exactly. And that's something that's, on a more philosophical level, that sort of tinkering mindset, like you said, is key. I mean, on one hand, it's very important to understand fundamental principles like variables and scoping and functions and stuff. But a lot of this, as and I'm sure a lot of people have talked to, software is really a craft, right? It's just like woodworking or being a carpenter or something. Like you have to learn some of the basic physics and materials science behind it, but really you can't just become an expert woodworker by just reading a bunch of books. You have to start tinkering and making mistakes and bruising your hands. And it's very similar. You have to write a lot of code, play around, see a bunch of errors, and just build up this intuition about how things work behind the scenes. And hopefully the visualizations help scaffold that learning.
Yeah, I think absolutely what they do. So, Very cool project. I think, Philip, that might be a good place to kind of wrap it up. Before I let you go, let me ask you 2 final questions I always ask guests.
Great.
First of all, what's your favorite editor?
Ooh, starting religious wars here. I've used
Hey, there's
Vim
no judgments passed. No judgments passed.
No judgments passed. So I started as an Emacs user in college for about a year or two, but then I saw the light and switched over to Vim a few years ago. So nice. I've been using Vim for, I don't know, the past decade or so. And I don't have any good reason for doing it beyond just muscle memory. So I am not dogmatic about text editors. I just think you should pick one that you work well in and just get really good at it, whatever it might be.
Yeah, learn the hotkeys, really just become comfortable. That's important. So the other question is, there's a ton of stuff out on the Python package index. You got any notable favorites out there? Things people should know about?
I think that one of the really useful Python packages is more of a meta package. So I think it's called this company called Enthought, which started as kind of a scientific Python company. They make some packages. There's one called Enthought Canopy, and then there's another one. I don't know which company does it, but it's called Anaconda. I think it might be Continuum or Enthought. Mm-hmm. But look up Canopy, Canopy, and Anaconda. And those are really all-in-one meta packages for just installing 100 or so Python packages and a nice one-click installer that contain, mostly it's meant for scientific programming. So it has things like the IPython notebook and NumPy, SciPy, Matplotlib, all the scientific packages, but also just a lot of stuff for data science, for data processing, analysis. The reason why I suggest those is, especially for beginners, is because they have a one-click installer for Mac, Windows, and Linux, I think. Because one of the annoying things about starting up with any kind of new language is just having to install extra packages. So, for people who are a bit more savvy, they can use PyPy, easy install, pip, those things. But sometimes they get annoying because you try to install it and it says, oh, some dependency is not found, or your operating system doesn't have this compiler and stuff. So
vcvars.bat not found.
Exactly, especially on Windows, right? Especially on Windows, development is hard. So the one-click installers, Canopy, Anaconda, they have a company backing them. I think there's free versions, and I just want to get past that headache and just get to the programming.
Yeah, especially if you're doing data science and you're doing it on Windows, I definitely second that, because it is super hard to get some of those things to compile over there.
Yeah, and one of the people have been talking in Python user groups and keynotes at like PyCon about how if you want to improve Python exposure, we need a better store on Windows, right? Because the current store on Windows it's pretty hard to get going. But these one-click package installers are going to help, and I'm hoping in the future, as web and cloud stuff get better, more of the stuff could be hosted in the cloud. So imagine a web-based Python cloud service where the web IDs are so good. I mean, I bet some companies are already starting to do this, that you can just have a web-based ID for Python, which is really responsive, and all your stuff just runs in the cloud. It has every single thousands of libraries available, so you don't even have to worry about installing. You just import whatever you want and everything works. I think that's the dream.
Yeah, that's definitely a cool dream. There's a company called Python Anywhere, pythonanywhere.com, and they're started down that path. It's not quite that far, but it is a pretty cool thing. It's free for people to try. That's pretty cool. All right. So, Philip, awesome conversation. Thank you so much for being on the show. Is there anything that you would like to talk about, to tell people about, that I forgot? A final call to action?
Final call to action. Wow, this is a high pressure here. I would say the call to action would be to find. Actually, here's a good call. A call to action is to go on YouTube and watch some of the videos that people have put up, especially talks. So PyCon, which is the main Python conference, has some great keynote talks, or just amazing. They're really good about putting up talks publicly. I mean, they have hundreds of talks on all sorts of topics, and they're well produced too. Like in PyCon, and also the affiliates in different countries. A lot of times what I do is I just listen in the background if I'm working or I'm doing errands. Both the keynotes, which are more high level, here's where Python is going, and also very very detailed things. Like if I want to learn about networking in Python, I want to learn about data science in Python. I think those videos are amazing. There's so many of them. I mean, it's just like
Absolutely.
There are thousands of them.
I totally second that. That's a really good suggestion. And on a more focus level for this conversation, I really recommend people go and watch your 10-hour code walk through the CPython code base. You will absolutely learn something no matter what your experience level is. It's very cool. So check that out.
Great. Well, thank you very much for promoting that, and I'm really glad I made this video. So I guess the final tidbit you want to include in the outtakes is that I didn't plan on producing those videos. I mean, those are just part of my class, and the great decision I made was I just turned on the screen recording capture, and I have a Microsoft Surface tablet, and that allows me to do a lot of the drawings and the more interactive things. But really, what you're hearing is exactly what I gave in those, I think, 10 lectures or so. That's exactly what the lectures were. I did some light editing, in the beginning, people were setting up in class and I did some light editing. But if you notice, the audio quality isn't amazing. That's the one downside, because I didn't have a nice mic. I just basically was teaching in front of the class. But I feel like maybe another call to action is for people, if you're giving a lecture or giving a talk about something, just record it and put it online. The quality doesn't have to be amazing, but it's just like the CPython walkthrough. It wasn't like I pre-planned to go to a studio and spend $10,000 making some high quality production. I just recorded this as part of my class. And, I said a disclaimer, this is kind of rough. Some parts are, I'm stuttering or I'm kind of backtracking or there are mistakes, but it's great to have the resources out there. And something like Khan Academy, which is really famous now with Sal Khan, making these very simple sketches explaining basic math and arithmetic. That's exactly how he started. He just was tutoring his cousins, and he had a pen tablet, and he just recorded videos. And he didn't care that they were kind of very impromptu. In a way, people really liked that because it seemed really genuine. It wasn't just some $1 million production in a studio somewhere. So,
yeah,
so I'm glad I put those up. And the cool thing is I didn't actually take much work. I just recorded it and did some light editing. I probably won't do as much editing as you'll do on this podcast, but and they're up and people happen to like them. So I'm glad that I did that.
Yeah, I think it's a great contribution to the community. So thanks for doing it, and thanks for being on my show.
Great. Thank you very much.
Yeah, see you later. This has been another episode of Talk Python to Me. Today's guest was Philip Guo, and this episode has been brought to you by Hired and CodeShip. Thank you guys for supporting the show. Hired wants to help you find your next big thing. Visit hired.com/talkpython-to-me to get 5 or more offers with salary and equity presented right up front and a special listener signing bonus of $4,000. Check out CodeShip at codeship.com and thank them on Twitter via @CodeShip. Don't forget the discount code for listeners. It's easy. Talk Python, all caps, no spaces. You can find the link from today's show at talkpython.fm/episodes/show/22. And while you're there, be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You'll also find the iTunes and direct RSS feed links in the footer of the website. Our music is Developers by Corey Smith, who goes by Smix. You should check out the entire song on our website at talkpython.fm. This is your host, Michael Kennedy. Thanks again for listening. Smix, take us out of here.
Stating with my voice, there's no norm that I can fit within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best.